Hi everyone, and welcome. Configuring the Linux kernel. I've covered already the steps in the previous class, so I'm just going to give you a brief overview. Now, if you need to download the kernel source code, you can either use the Git application or you can just download the tar file over the HTTPS connection. Now, to use Git, you're going to clone the repository, and then you're going to jump into the main directory, and then you're going to switch to the version of the kernel that you want. And then it's going to be much easier if you download just the tar file, but that's less flexible. Okay? Now, once you download the source code, you're going to end up with something like this, with a bunch of directories and files. In here, I just describe a few of them for you. Okay, so we have the architecture directory that contains architecture-specific files. And then we have the drivers, which contains device drivers, the FS, which contains code for all file systems supported by the kernel. Additional binary formats, such as the Java one, can be defined here. And then again, the include directory, which contains kernel header files, the init, which contains kernel startup code, the kernel directory itself, which contains core functions such as locking, timers, power management, debugging, tracing, and scheduling, the which contains files data structures that are used by the system to manage memory-related issues. The net directory, which you might guess has something to do with networking, and you will be correct. In fact, it contains the repository for the socket abstraction and the network protocols. Then the script directory, which contains many useful scripts. The tools directory, which contains useful tools for profiling and tracing, and many more. Configuring the kernel with Kconfig. By configuring the kernel, you can reach maximum flexibility. The configuration system is called Kconfig, and it's documented in the documentation/kbuild directory. This step aims at configuring a bunch of files that will drive the build of the kernel. The configuration process can be text-based if you run make config. So yes, we're going to be using make to create the kernel configuration files. Also, the configuration process can be ncurses-based if you run make menu config. It can be qt-based if you run make xconfig, and it can be JTK based if you run make gconfig. Obviously, you're not going to be able to run the JTK based application if you don't have the JTK library installed in your system. Always use make help to explore all possibilities. When the chosen configurator starts, it reads the main kconfig file located in the appropriate architecture subdirectory. If the user does not set the architecture variable during the configuration step, the system will default to the local machine architecture. And this is how you should be calling the make menu config or make xconfig or whatever. This is how you're going to be running the configuration step. You need to specify the architecture, right? This main kconfig file contains references to additional configuration files declared using the following syntax, right? Source, and then the directory with the name of the config file, which is kconfig. These external files can also contain references to additional resources that are included by using the same syntax. So again, source and etc. Let's see how these Kconfig files are structured. So each line starts with a keyword, which may be followed by multiple arguments. The config keyword starts a new configuration, while the following lines define attribute of this configuration. So we have the configuration name, LCD, and then we have something that looks like a Boolean value. Depends, which might mean that there is some dependency, some configuration that depends on something else. Help, which is likely to be an help message, right? Type definition, we might have a Boolean, like in this case, which obviously yes, no. Tree state, string, hexadecimal, or integer. Tree state for a configuration option can be yes, option is enabled, no, option is not enabled. M, option is set to be built as a module. Input prompt is used to display messages to the user. As type definition also accepts input prompt, the following bool install drivers is equivalent to bool prompt install all drivers, right? Because the prompt is gonna be inheriting the bool definition on the previous line. Default values. They assign default values to a configuration. Dependencies for specific values can be specified using if. Therefore, the following: default yes if LCD means that the default value is yes if LCD option is also activated. Default values are always set to no otherwise, and these should not be changed unless a different value is actually needed. Dependencies. Dependencies define dependencies for this menu. Multiple dependencies are defined using && syntax. Dependencies are applied to all options within the menu. Right? Therefore, the second and third line of code also inherit the dependency defined in the first line. Reverse dependencies. Normal dependency restrict the upper limit, while reverse ones restrict the lower limit by using the keyword select. The lines above mean that if use a stack radio button is checked, the system will also need B graphics needed. Reverse dependencies. The keyword imply instead allows the symbol's value to be changed by direct dependency or via visible prompt. Now here, if A is set to no and B is set to yes, then C is set to no, but C can also be changed to module and yes. While if A is set to module and B is set to yes, then C is also set to module, although it can be changed to yes and no. Menu visibility. That's an attribute that only works for menu blocks, turning their visibility on and off. Help text defines help text whose end is determined by indentation level. The following two are equivalent. Menu structure. The position of the menu entry in the tree is determined in two ways. Number one, using the keywords menu and menu. Number 2, analyzing all dependencies as a menu entry that depends on a previous one can be displayed as a submenu of it. One of these two conditions must also be true. If parent is set to no, the child has to be invisible. The child is visible only if the parent is visible. And here we can have a look at the menu structure. So we're using the menu and menu, and you can have a look at the comments. And on my move next, you can pause the video if you need. Here, the same thing, but we're using the dependency approach, right? Again, just have a look at the comments and you'll figure it out what it means. And again, if you need, you can pause the video. Okay, so in Kconfig files, each line starts with a keyword, apart from comment text. Some keywords are also used to end a menu entry. Okay, let's have a look at some example. Make menu config. I'm not specifying the architecture, like I should be saying right? But we don't need it at the moment. It's just an example. Okay, this is what the menu config looks like, and you can browse the option, etc. Exit. Do you wish? No. Let's have a look at the make Kconfig, which is the same thing, but it looks more modern. It looks better if you wish, right? Quit. And then let's try Gconfig, which is going to fail because I don't have these libraries over here installed on my computer. Okay, so more example. And we look for the USB because nowadays you can plug pretty much anything on this USB. And then okay. Here it is. USB support. Okay. So help, right? So we have the description. Now I'm here and I can go into drivers, USB, and then in here I can do vim of this file, right? And over here, see, USB support, and I get some help text, right? Let's have a look at this help text again. So this option adds core support, right? This option adds core support, blah, blah, blah. So it's the same, right? Default yes, depends on as IOMM, right? And in here, we have this if block, which means that it's all included until the end if, right? And then we have a bunch of external configuration files that have been added, right? Now select again. If you remember, select means if USB is on, then select generic allocator USB and NLS also has to be on, right? Or yes, if you prefer. Okay, so let's have a look at this again. So we have USB support, USB LED trigger. Do we have LED trigger here? Well, if it's not here, it's going to be in this additional configuration file. So I'm gonna go and then again, what's the path? Drivers USB common. Sorry again. Drivers USB common. Okay. 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 Here it is, in fact. So we have USB LED triggers, which comes from this external configuration. Sorry, this one. Right? So you have USB, which is this menu, and then you have this one over here, LED triggers, and then you have this one over here, again from the external file, and so on. Right? Let's have a look at another file. So sound USB. In here, for example, we have this dependency over here. So x86 or PPC, PowerPC, or Alpha, right? Interesting. Then some help text, and pretty much the same. And the last thing you need to do is creating the actual configuration. I'm not gonna pass any architecture, but you should, obviously. That's just a test. And I'm just gonna do save. Okay. Exit. And I'm gonna inspect my file. Here it is. As you can see here, all property start with this config underscore, while in your Kconfig file you don't have the config underscore part, right? It just makes it easier to manage it. Okay? And this slide is going to give you more information about what you've just seen. Configuring all Kconfig files correctly will allow the configuration and build steps to run smoothly. It is now possible to run the configuration procedure, as you just seen, using any of the available options as explained before. Make sure that architecture match your architecture, right? I didn't set any because it was just a test. At the end of this step, the chosen procedure will save the configuration file called .config needed to build the kernel. Now, let's go back to the terminal. I'm here. Oh, as I said before, this system is based on makefile, right? I have my makefile over here. And then I choose a random directory, and there is another makefile, right? And then I get another directory over here, and there is another one, right? Okay, so what's happening? Now, how do config files drive the build? The main make file reads the .config file and does its job, while analyzing all subdirectories recursively. The main make file reads the one located in the usual architecture directory in order to gather architecture-specific information. Right? All make files present on each subdirectory will carry out commands passed from above. Configuring the kernel from scratch is a big job. Therefore, it's possible to use non-config files stored into the usual architecture directory /configs. The .config file can then be created using the usual syntax. Now, the following reads a configuration compatible to many ARM version 7A machines. So if you run that last line, you can end up with the .config. Okay, displaying the kernel version. To check the version of the kernel by analyzing its source code, so basically the code you just downloaded, you can use this line over here. Now this will print the same string than the uname, right? The Linux command. If it's necessary to modify the default kernel configuration, then the config local version should be also modified, the variable. Now, if the config local version is modified, the following command will print the same information than before, the kernel version, while the second line will show the differences, the new release, right? Kernel modules. While desktop Linux distributions do use modules extensively, embedded devices do not, as their hardware and software configurations are known at the time the kernel is built. Therefore, embedded kernels should always be built without any modules, unless it's crucial to reduce boot time by deferring loading of non-essential drivers, avoiding licensing issues with proprietary modules, reduce compilation time when it's necessary to support a very large number of drivers. And that will be all for today. I hope you've enjoyed my class, and thank you very much.